For example 1, it says that you're going to use the AA, or the angle-angle similarity postulate. Determine if the triangles are similar by angle-angle similarity, and if they are, write a similarity statement. So we know that vertical angles exist here, which are congruent to each other, plus we're given the other angles of 45. So yes, these are similar. Okay, so yes. And then I went ahead and had the triangles set up for you here, like listed. So all you're doing is recopying that with your similarity symbol in between them. Okay. For B, looks like we're going to do a little bit of math. So we're going to have to add 30 and 70 to get 100. Subtract that from the 180, and you get that angle K is 80. Then if you add these two together and subtract from 180, you get that this is 25. Well, even though the 70s match up, the 30 and 25 and the 80 and 85 do not match up, so this means these are not similar. For the letter C, we're given the right angles, 90 and 90, they match up. Then we're given these different angles here, so we need to do that math again and figure out angle S and figure out angle H. So if I add 90 and 39, subtract from 180, we get that this is 51 degrees. And then if we add 90 and 51, subtract from 180, we get that this is 39. And as we can see, they match up. So we can say that yes, these are similar by the angle-angle postulate, and our similarity statement is listed here. Okay. In letter D, again, we're going to have to add 68 and 54. Subtract that from 180. We get that this is 58 degrees, angle B. Then again, we add, subtract from 180. We get 49 degrees. So we start comparing, okay, 68, 68. Okay, that's good. We have that. But 58 doesn't match up to anything else. 63 doesn't match up to anything else. So no, these are not similar. In letter E, we have 67, 91. We can add those, subtract from 180, and get that this is 22. Now in the big triangle, this is also 67, 25. If we add those, subtract from 180, you get 88. So we can see that 88 and 91 don't match up, 22 and 25 do not match up. So again, no, these are not similar. And then lastly, we are given that these are congruent. And we also know that the vertical angles are congruent. So yes, we are given two angles that are congruent in the triangle. So triangle PXQ is similar to triangle ZXY. Okay, moving on. We have the side postulate. So here we're doing more fractions and reducing to check to see if we have the same fractions. Okay. So if we compare, like 10 would go to 15. And if you couldn't visualize that, you could check, okay, US is right here. That would go with WX. So 10/15. Then ST is 6. So XV is 9, so 6/9. And then lastly, 8/12. So if we reduce each fraction, we get 2/3. 2/3 again. Reduced by 4, we get 2/3. So everything is the same. It's all proportional. So since we have all the sides proportional, yes, this is similar by side, side, side. And then again, we have to write that similarity statement. In letter M, okay, we can compare 5 to 18, 15 to 54, and then 12 to 43.2. Okay, so first, 5/18ths can't reduce, but 15 54ths can reduce by what? 3. So that means 3 goes into 15 5 times. 54 divided by 3 would be 18. So far, these match up. But what about this decimal? So here's what you need to do. Because you have this 0.2 in the tenths place, you're going to multiply this fraction by 10. Okay, so I actually multiply the top and the bottom by 10. So my new fraction is 120 over 432. And that is important because this gets rid of my decimal, the 0.2. And then I reduce this. And to reduce this, you could keep dividing by 2 if you want, because they're both even. But I will just tell you that 24 goes into both of these evenly. And so if I divide 120 divided by 24, we get 5. And if we get 432 divided by 24, that's also 18. So, are these similar? Yes, all the sides are proportional because they all get 5/18ths. And we can go ahead and write our similarity statement.